Hello and welcome back. Our previous video did a deep dive into John Rust's 1987 econometric paper about replacement of GMC bus engines in Madison, Wisconsin. This was an excellent application of a lot of the concepts that we've built up throughout this video series. However, in one of the footnotes of his paper, Rust highlights the fact that the discount factor is not typically separately identified from other parameters in the utility function in these sorts of models. So I wanted to briefly discuss how we might be able to separately identify parameters governing utility and the degree to which a decision maker is impatient or myopic. We'll discuss how clever researchers have deployed so-called intertemporal wedges, which are variables that affect future states without affecting present utility. In most cases, the discount factor is actually not identified, and typical practice is to calibrate it. However, I do think it's useful to go through conditions under which we might be able to identify the discount factor and also show examples of where it has been done. So let's go to that part of the Rust paper where he talks about this identification problem and then build on that from there. If we go to footnote 12 of the 1987 Rust bus engine paper, it says, the identification of beta, which is the discount factor in that paper, depends on a priori specification of the utility function u. Actually, beta is non-parametrically unidentified. In the absence of a priori knowledge of the form of u, it is impossible to infer beta. And then he goes on further and says, while this theoretical result might appear disturbing at first, on reflection it is clear that we often do have substantial a priori information about beta itself. In the case of Harold Zurcher, we know that beta must be large because beta equals 0 implies an implausibly large rate of increase in monthly operating costs. So here he's just saying that we can actually sort of infer that beta is not 0 just by looking at what would have to be true if beta were equal to 0, and then note that that would be a very implausible world compared to the data that we actually see in the real world. So basically, Rust's argument is that the discount factor beta and the utility parameters theta are confounded. And so there's two observationally equivalent explanations for the behavior that we see. So one, I could be an impatient person with a low discount factor, and I would just say, I don't care about the future, I only care about now. But I could also be somebody with a high beta, but my future utility just happens to be low. So I care a lot about the future, but it's just not very valuable to me. And so we can't really distinguish between these two types in the data without adding some additional restrictions of some sort. So Rust's suggestion is to impose strong a priori assumptions about the utility function. So for example, we could assume that the utility was linear in maintenance costs. And in his paper, he goes through a bunch of different utility specifications where the cost function takes on different forms. But if we assumed that it was this simple linear function, then we could identify beta based on the intertemporal trade-offs that Zurcher is facing. But the problem with this is that the assumption may not be correct that utility is linear in the maintenance cost. And Rust points this out in that same footnote 12. He says the difference in the log likelihoods for the myopic and the beta equal 0.999 case disappears as I generalize the specification of the cost function C. So he's just saying if we let the cost function be more flexible, then we lose the ability to separately identify the discount factor. So these two things are confounded in his example. So how to get around this? Well, besides making strong assumptions about the shape of the utility function, we could alternatively find variables that affect state transitions but not flow utility. So if we have such a variable zt that affects the future state given the current choice, but does not affect the utility of the current choice or at the current state, then we can use this to separately identify the discount factor from preferences. So basically this variable z is going to create variation in the future consequences without changing the current payoffs. And so we can tell if somebody is forward-looking or not based on how they respond to this z, or if they respond at all. So basically myopic agents would be making the same decisions regardless of what the value of z is, but forward-looking decision makers would be responsive. So one example from this is from a 2007 paper in the International Economic Review by Peter Arcidiacono, Holger Sieg, and Frank Sloan. And in this paper, they're looking at elderly people and their decisions to smoke or consume alcohol. And the thinking here is that why do elderly people consume these types of substances if they're damaging to their health and they're near the end of their life? And what they come up with is using age as this additional variable that can separately identify the discount factor. And basically they show or they assume that age affects health transitions, but doesn't affect the utility of consuming these substances. So mathematically, age does not enter the utility function, but it does affect the transition probabilities. So how does this identify beta? Well, we can look at the profiles of age and consumption, and this would reveal the degree of forward-looking behavior of that person. So when we say age consumption profiles, we're just saying like, okay, a dynamic model would predict that smoking rates would decline with each additional year of age by so much. And myopic model would just reveal that they always stay the same, just for the sake of example. That could be true. So if someone was a forward-looking person, they would reduce the consumption of these harmful substances as they grow older because there's a shorter time horizon in which to live. But a myopic person would only care about the instantaneous utility, and so their consumption patterns wouldn't really change as they grow older. And so we can look in the data to see which of these models fits better, and that's what they did in this IER paper. So the main idea is that we can leverage variables that create intertemporal wedges. And what are these wedges? Well, they're just variables that change the future consequences of current actions, but not current payoffs. So what are some other examples of this? Well, we could think about policy changes that would affect the future, but not the current environment. So if the government announced a tax change that would take effect 5 years from now, then forward-looking people would change their behavior today in anticipation of that tax change occurring, whereas myopic decision makers would not change their behavior. Same thing with maybe there's variation in the information about future states. So maybe you are graduating college and you decide to go into a field that has a really volatile wage schedule. So it's like a feast or famine in terms of whether you get paid every month. And then we can compare that with somebody who just went into a very stable pay field. And we can compare the savings behavior of those two sets of people. And so that's kind of the idea behind this statement that variation in information about future states could be used to pin down the discount factor. And then similar to the example that we just gave with age in the IER paper, individual differences in transition probabilities could also help pin down the discount factor in the way that we discussed with age and smoking and tobacco. So in summary, the forward-looking behavior will reveal itself by how responsive people are to these intertemporal wedges. In general, I would say that the discount factor is typically not identified in most models, but it's helpful to think of cases where it could be and then think about how we can leverage that in our research and we can learn more about the world and about how people behave. This brings our mini-series on dynamic discrete choice models to an end. We've covered quite a bit of material, building up from first principles and seeing how dynamic programming and Bellman equations can be used with the discrete choice framework that we've been discussing in recent weeks as well. So I hope that you've been able to find something useful out of these videos and that you've gained an appreciation for the work of John Rust and others of his era that really developed and pushed forward the tractability and usability of these types of models. Our next mini-series will cover recently developed techniques for getting around the nested fixed point way of estimating the utility parameters of these models. So in the next series, we'll cover what sort of strategies we can employ to not have to do backwards recursion or fixed point methods to solve the model. We can just estimate the model without solving it. So I hope that you'll look forward to that one as well.